what does it mean if we say that they are unsaturated? What is it they are not saturated with? Hydrogen. That means that they're either going to have a carbon-to-carbon double bond or a carbon-to-carbon triple bond. And so we'll start by looking at the alkenes. These here are going to have a carbon-to-carbon double bond. And then we have the alkynes, and these here are going to have a carbon-to-carbon triple bond. And I see that these are all named very conveniently. The alkanes, which is what we started with, then we have the alkenes, and we have the alkynes. And here's a handy little mnemonic so you can keep them straight. Alkanes, the only type of bond present in those would be single bond. Alkenes have a double bond, alkynes have a triple bond. And so if you learn them alphabetically, alkane, alkene, alkyne, then respectively you have single, double, and triple bonds present. So alkane, alkene, alkyne, single, double, triple, as far as the bonds that are present. Now this here is the simplest of the alkenes. Simplest of the alkenes. If I were to open up this bond, how many hydrogens could I put in?
2.
You could put in 2. So if we look at a general formula, whenever we put in a double bond, the same is true here. If I open this up here, we could put in two more hydrogens. So if we compare the general formulas of an alkane to an alkene, the alkenes are always going to have 2 less hydrogen atoms. Which means then, if we want to write in a general formula, if the alkanes had a CnH2n plus 2, the alkenes are going to have a formula of CnH2n. Because again, they're going to have 2 less hydrogens than an alkane. The alkynes, these have a carbon-to-carbon triple bond. If we open this up, we can put in how many more hydrogens?
2.
2. If we open this up, we can put in
3.
2 more hydrogens again. So each one of these, every time we open up a bond, we can add in 2 more hydrogens. So these here are going to have a general formula of CnH2n minus 2, because they're going to have 2 less hydrogens than an alkene. So now, if we want to name these, we'll start with the 2 simple ones that we want to name here. And we'll start with this one here. We're going to write out the condensed structural formula for this one. We'll write it as CH2 double bond CH2. And if we want to do it for this one, we'd write it as CH triple bond CH. Now, should mention that, and I neglected to show it on our earlier models today, but we talked about this last Thursday, and that is sometimes the leftmost carbon, we sometimes write the hydrogens on the left-hand side. So we could write it like this, and likewise on this alkyne, we could write it like this as well. And so you're sometimes going to see, and I think that's kind of a favorite thing of your author, if we'd gone back, any one of these that we showed the hydrogens written on the left hand of the leftmost hydrogen, we could have just as well written the hydrogens on the outside as well. And it means the same thing. I was taught, though, that we always write hydrogens on the right, and that's kind of the way I learned it, and so that's the way I like to teach it. But either one of those is a correct way of doing it. So now, when it comes to naming these, then what we're going to do is we go on to our naming rules down to the very bottom. And the first thing I want to mention here, first of all, the naming rules, is right here, and this note. You can highlight this one. In Chem 1020, you are only going to be responsible for the straight chain alkenes and alkynes. And by straight chain, that means we're not going to worry about naming any branching, because the nomenclature of branched alkenes and alkynes get to be way more complex. And that's why we have year-long courses in organic chemistry, is because the naming gets to be much more complex. And furthermore, it's not just as simple as alkenes and alkynes. We can have such things as dienes and diines, and trienes, triines, and eneines, and there are all sorts of combinations of these things in there. If we had a diene, that would mean that it would be something that has two double bonds in it. Or if we had a eneine, it would be a double bond and a triple bond. And so the nomenclature of those gets to be much more complex very rapidly. So, again, we're going to look at these right here, and we're only going to be responsible for the straight chain alkenes and alkynes in this particular class. And then what we see here is for the alkenes, what we do is we count the number of carbon atoms in the molecule. And so if we're looking at this one, we count the number of carbons, which would be a total of 2. We write the name of the alkane that has the same number of carbon atoms. So a 2-carbon alkene would be called ethane. But if it's an alkene now, we replace the A and E suffix with ene, and so we'd call this one here ethene. This one here is the carbon-to-carbon triple bond, so we would call this one ethyne. So we have ethene for this one and ethyne for this one here. So again, the names, it irritates me that my thing doesn't like to scroll. So ethene, and this one here would be ethyne. Which then takes us down to the last models that you were to build here at the beginning of the hour here today. And so what we're going to look at is the isomers of C4H8. And so we'll go ahead and pull out some models that you built, if anybody has them here yet. We'll grab this one. And we have a short of hydrogen. Anybody else have one here? Okay. Anybody have one? Good. Thank you. Here's 2 of them. There's 2 more isomers for them. And I need another one. That's a different one there. Yep, that'll work. There's one more up here. That should be the easiest one. That's actually an isomer as well. This one's not going to be an alkene though. This one's kind of a cool one though. If you look at it, this is a cyclic structure. This has formula C4H10. This is called cyclobutane. But we're not going to be doing cyclic ones in here. There's one more though that has a double bond. Carbon-to-carbon double bond. You got one there? Yep. So we got 4 different ones here, and we have a cyclic one back there. So now, let's not click our marbles. There'll be time to click your marbles at the end. Let's remove the temptation. Just set them down. Set them down, please. And let's not click the marbles, because somebody's going to lose them here really quick again. Okay, so what we're going to do is we're going to want to make a distinction between these 2. First of all, consecutive carbons in the chain would be how many? 4. So if we have a 4-carbon alkene, these would each be called butene. It would be butene. The prefix but means 4. And we have an E and E suffix because it has a carbon-to-carbon double bond. But now, what's different between these 2?
Where the double bond is.
Where the double bond is located. Here it's between carbons 1 and 2. Here's between
2 and 3.
2 and 3. So now what we do with the alkenes is we count what are called slot positions. And by slot positions, that means if we have 4 atoms, there's going to be 3 slots. If we had 8 atoms, there's going to be 7 slots. It's just like if we have 4 people in the back row, how many spaces are there?
3.
There's 3 spaces. So the number of spaces is always going to be
1 less.
1 less than the number of people, or in this case, 1 less than the number of atoms that are in there. So this would be located in slot number 1. This one here is located in slot number 2. So then if we look at the rules, we want to name these, and we're going to go ahead and draw these out. We'll put the first one in. We'll look at it like this. We've got CH2, they have a double bond, CH, CH2, CH3. And if we look at the next one here, we'll see that this one is written as CH3. Then we have a CH, then a double bond, CH, and a CH3. So if we follow our rules now, and we go on to the flip side, it says we're going to locate and assign a number to the slot position of the double or triple bond. We'll count in the direction that gives us the lowest number. We'll then place that number in front of the entire name, separating the number and the name with a hyphen. So this one here, well, we'll start with this one. This first one is going to be called
2-butane.
butene. But the number that's going to go in there would be which number? 1, because this here is in slot number 1 in the molecule. And the next one, this would be called
2-butene.
2-butene. And it's going to be called 2-butene. And again, that's because this here is located in slot number 2. So now, we then look at the difference between these two. We start counting consecutive carbons. This is the one we just looked at. So look at this one. How many consecutive carbons in this one here?
4.
There's 4. We look at where the double bond is located. It's located in which slot?
2.
It's located in the second slot. Okay, so if this is 2-butene and this is 2-butene, what is the difference between the two?
The formation.
The formation. And remember, there's one distinction about double bonds that's different than with single bonds. One feature of double bonds is
Can't move.
can't rotate, you can't spin them around. So in this one here, these two are locked in on sides that are opposite of each other. We call this type of isomer a trans isomer. In this one here, these two groups are located on the same side of that double bond. And this type of isomer is called a cis isomer. And so think of it like this. Trans means across, like transatlantic. Okay, transatlantic. This one here, they're cis, they are on the same side like sisters. Okay? That's a way to think of it. So then, when we want to draw these, what we do is this. We want to start with a backbone. When we want to show cis and trans, we always start with a backbone, and that backbone will always look like this. We start by showing that carbon in the center and these bonds coming off of each side. So again, when you want to show the distinction between cis and trans, always start with a backbone that looks like this. Now to make a trans 2-butene, we need 2 more carbons. And a trans, they must be on sides that are opposite of each other. So if we put one here, the other carbon would go where? Up above. And remember, we could also put it up here and down below. It would be the same thing. So put it down here and here. These become hydrogens. Down below, this is a CH3, and up above, this would be CH3. Then if we want to show cis, if we put a carbon down here, then the other carbon would go where?
Same stuff.
Right over here. So there'd just be a different carbon atoms. So we'll put a carbon down below, another one down below, or we could put both of them up above. It doesn't really matter which one we do. Then if we add in hydrogens, this would have 3. This one here would have 3. Down below, 1, 1. And then to name them, what we're going to do is we look at the parent chain. The parent chain in each one of these cases has the 4 carbon atoms. And there's a double bond in there located in slot number 2. So at slot number 2, then it's going to be called 2-butene. This here is also 2-butene. But then to deal with the cis and trans, says what we're going to do here is that the prefix cis or trans is written before the slot position. In this case, trans 2-pentene. So if we wrote it in, this one here would be trans 2-butene. This last one here would be cis 2-butene. In this last one, this is a Chem 1020 class, so because it has branching, that's a branched alkene. We are not responsible for naming this one, so we don't need to worry about the name. I am going to write it down just so you have it, but I know you guys want to get your stuff packed up here as well, so I'll just write out the structure, and I will tell you the name of it. So CH2, CH3. The name of this is going to be 2-methylcopene. But I will asterisk this one here as being one that you do not need to be able to name because it is a branched alkene. You are not going to be responsible for naming branched alkenes in here. So any questions? 5, 4, 3, 2, 1. And I do see some of the answers up here, at least honest, IDK. The name here is 2-pentyne. There's actually another correct way to write it, but we will not be writing it that way. We'll be writing it as 2-pentyne as the name. Now to arrive at the 2-pentyne, let's talk about how we arrive at that name. First of all, let's talk about the suffix YNE. Where does that come from? Triple bond, right. We have a triple bond, ends with YNE. If this was a double bond, it would end with ENE, and if they're all single bonds, it would be ANE. Where does the pent come from? 5 carbon chain, exactly. So we talked about the number one key to success with these is the ability to count consecutive carbon atoms in the chain. So that then would be the pent in the pentyne. And then where does the number 2 come from?
The spot is bonded.
Right, the spot where this triple bond is located. And recall, when we talk about alkenes and alkynes, we talk about the slot numbers. So we count in the direction that gives us the lowest slot number. We count in this direction, left to right, which is 1, 2, 3, 4. Or this direction, 1, 2, 3, 4. And we always go in the direction that gives us the lowest number. So counting left to right is the direction that gives us the lowest number. So we are going to go with the sequence of numbers here on the top. So any questions on how we arrive at this name? All right, then let's try this one. I'd like to arrive at a name for this one. Before I write out the complete name, let's just talk about how we classify it. How is this one here classified? Alkane, alkene, or alkyne? Again? Alkene, because of the double bond, carbon to carbon double bond. So that means the suffix of the name would end with
Ene.
E-N-E. How many carbon atoms are there altogether?
8.
So it's going to be octene. Then we want to tell where this double bond is located. It's located in slot number 4. Because we count 1, 2, 3, 4, or in reverse 1, 2, 3, 4. So I guess in this case it doesn't really matter which direction we count. So we then call it 4-octene. With this one we need one more piece to the puzzle though in its name, and what would that be? Okay, now this is kind of where we left off in class the other day. We flip over to page 2 of our handout. Page 2 of our handout, which is right where? Here we go. Page 2. It says for alkenes, if the double bond is located in any slot position other than the first, you must tell whether the alkene is a cis or trans isomer. So look carefully here at the location of this double bond. You want to tell where these pieces are located. Are these on the same side of the molecule or on opposite sides? They're on opposite sides. This makes it a trans isomer. If it was cis, then it's going to look something more like this, where these two pieces are on the same side of that double bond. So you look here at the double bond, you see that both of these attached groups are on the same side. That makes this one here cis. And this one here, we go and put it back. This is the way we looked at it originally. We looked at this double bond. We see these two pieces that are attached across or opposite from each other. That makes this a trans isomer. So we come back here, we want to write that name out, and the name that we wind up with, trans 4-octene, trans 4-octene. Then if we want to write out the structure for this, I'll set it down here. If we want to write this out, if we want to show the difference between cis and trans, where do we begin on this? We begin with a double bond. So we show the double bond. Remember that we want to show cis and trans. We always start with this backbone. Then we want to build. It doesn't really matter where we start. Let's say we start here in this upper left-hand corner. I'm going to put in a carbon here. And if I put in enough carbons to show a number 4 position? No, because right now it will actually be showing 1, 2. So how many more carbons do I need to put on here to make this into the 4 slot?
2 more carbons.
2 more carbons. So I'm going to put in 1, 2 in here. And this now makes this so it's in slot 1, 2, 3, 4. But now I have 1, 2, 3, 4, 5 carbons altogether. How many more carbons do I need to show?
3.
3 more. And where am I going to put those 3? Am I going to put them in position 1, 2, or 3?
2.
I'm going to put them in 2 because, again, we want to show a trans isomer, so they have to be across from each other. So we put in here, and how many carbons do we want to put down here altogether? 3 more. So we'll put them on in. And then we're going to put in CH3. This will be CH2, CH2, and then down here CH2, CH2, CH3. And what goes into each of these positions here?
1 hydrogen.
1 hydrogen, exactly. We put those hydrogens in on opposite sides. Then it's always a good idea to count our number of hydrogens to make sure. We already know that we have 8 carbons. So since it is an alkene, how many hydrogens should there be?
18.
I hear 18, I hear 14. Neither one is correct. Well, I go back. We look at what we did the other day. We talked about the general formulas. General formulas of an alkene would be CnH2n. So that means there should be how many hydrogens altogether?
16.
16. So then we count on here. We have 3, 5, 7. This makes 8, 9. That's 11, 13. That's 16 altogether. So it's always a good idea to check your numbers of carbons and hydrogens to make sure that they correspond to what we would expect. Any questions with that? Okay, let's try drawing out these structures. Actually, I'm going to give you one to draw out, and then I'm going to give you one to name. So let's draw this one out. Let's do one hexyne, and then I'm going to put one down here that we're going to name. And so the one that we'll name will be this one here. First one we want to write out a structure. The second one we want to assign a name. What distinguishing features should we look for in this molecule? Triple bond. And that triple bond will be located between 1 and 2. All right, so we're going to show a triple bond. And the first carbon should have how many hydrogens?
1.
And the second carbon should have how many hydrogens? 0. So then we'll put in CH2. Then what? CH2, CH2, and CH3 for a total of how many carbons? 6 carbons. How many hydrogens should be in there? Should be 10. Because the general formula for an alkyne is CnH2n minus 2. So this should be one hexyne. Any questions on this one? All right, the next one. Let's just start with the name. It would begin with cis, then we need a number in there. I hear 2, 3, and 4. It would be 3. And then the name would be heptene. Cis-3 heptene. We talk about where the names come from. First of all, it's cis because they're on the same side of the double bond. We look at the double bond here. Again, these are both on the same side of it. That makes it a cis. As far as the slot position, we count from left to right and come up with 1, 2, 3, 4. Or in reverse, slot 1, 2, 3. So we go in the direction that gives us the lowest number. That's going to give us slot number 3. The hept comes from 7 what? 7 carbon atoms, and the ene suffix is
The double bond.
the double bond. So any questions on this name? Any questions on the name?